All right, number 17, we have 40 divided by 2 plus 6i. Okay, the way these problems work is we want to get rid of the imaginary on the bottom, rationalize the denominator. And in order to do that, we're going to be pretty much applying that difference of squares method. It's called rationalize the denominator, but the way we get rid of these, that we rationalize it, is by using the complex conjugate, which basically comes from the difference of squares. So remember, the a plus b, and then the a minus b is equal to a squared minus b squared. So when that bottom term gets squared, it gets rid of the square root. And remember, I is like a square root of -1. So what we're going to do, the complex conjugate is going to be 2 minus 6i. It's always going to be the same two numbers, just change the sign in the middle. So if it was a minus here, then this would be a plus. You're going to multiply that on the top and the bottom. 2 minus 6i. Alright, so with the 40, I'm going to multiply 40 times 2. That's going to give me 80. 40 times 6, that's going to give us 240. It's going to be a negative 240i with that I there. So that's what I get for my numerator. Now on the denominator, I'm going to go ahead and jump to shortcut. So remember, same terms, one is adding, one is subtracting. I can just rewrite them with squares on them. So I'm going to go ahead and do this. So this is going to be 2 squared, which I'm going to write as 4. And then 6i squared is going to be 36i squared. And then we're going to simplify. I squared is equal to -1. So the top is going to stay the same. 240i. The bottom will become 4 plus 36. So y plus, remember, I squared -1. -1 times a negative is a positive. Therefore we get plus 36. Okay, so then we have 80 minus 240i over 40. And then we're going to reduce. So both these terms are divisible by 40, so we're going to divide out 40. 80 divided by 40 is 2, and 240 divided by 40 is 6. And we've got to bring down our I. So 2 minus 6i will be our final answer. It's weird that it came out to be the complex conjugate, but it worked out that way this time. So we're going to do the same thing with number 18. We have 4i, 1 plus 5i. And the complex conjugate this time is going to be 1 minus 5i. So same process, we're going to distribute 4i in the numerator. 4i times 5i, that's going to be 20i squared. It's going to be negative. A positive times a negative here. On the bottom, we're going to go ahead and do the difference of squares formula. So it's going to be 1 squared, which is just 1. 5 squared is 25. And then the I squared. It's always minus when you do those. Okay. And then this I squared, I'm going to convert to -1 as well as this I squared. So I'm going to simplify both of those simultaneously. So it's going to be 4i. Negative times a negative, this is going to be plus 20. Negative times a negative, this is going to be 1 plus 25. And then final answer, I'm going to rewrite this in order real number out front. So 20 out front, and then plus 4i over 26. We can reduce. All of these are even, so we can divide them all by 2. Divide by 2, this becomes 10. Divide by 2, that is 2i. Divide by 2, that is 13. Now, if they wanted you to write this in standard form, the a plus bi, the real number part, you would do 10 over 13 separately. And then the imaginary part, you would do 2 over 13 and the I. I think they will accept either one. I'm going to write it in the a plus bi form. I'll do the division bar first. 13 plus 2, 13, and then add the I at the back. You should be able to take it that way as well.